Hi everyone, welcome to the first devlog for WhiteBox. I wanted to give a quick introduction to some of its basic features. It's a live debugging and visualization tool that gives you information about your code as you write it. WhiteBox compiles the function you're working on in the background and runs it, picking out the values of variables as it goes. The top right of the screen shows an example of code that I might be working on. The left of the screen shows the output from WhiteBox. Functions need to be given some inputs to run, so the bottom right is a temporary way of providing those. This is not what the UI will look like, but this will hopefully serve to demonstrate some of the tool's features. You can see that the cursor on the right is in basic function, called with arguments 3 and 4 from the bottom right. On the left, the output shows that the variables a and b didn't change after their initial value. Result only changed from an invalid state when it was defined in line 2. Even though the software is called WhiteBox, we can also see the black box report of the function. That is, given these inputs, what output is produced. When I update the code in basic function, you can see that the output updates as the function is recompiled and run. In this case, the output doesn't change because b has the value of 4, which is less than the while loop value 5. Let's alter the inputs to basic function and see how things change. As you can see, when the calling code updates, the function is rerun. Now, b is bigger than the while loop value by 2, so the while loop runs twice, updating the result twice. The updates to b are currently not being shown as they don't occur inside a statement. The output becomes far too long later in this demo if the value after every instruction is shown. With a decent UI, this won't be a problem. What if I want to compare two sets of inputs? I can put both in the function caller, and there's a quick comparison at the bottom. Or you can see what's going on in more detail at the variables section. The text output doesn't make the distinction very clear, so I've added an indication of which changes belong to which run. The function caller code is compiled as any other, so you can put pretty much any arbitrary code there. Here's the function being called in a loop. Let's try a different function. You can see when the cursor moves into fib function, the output updates to show that it is now trying to run it. I've suppressed error messages here for brevity, but it isn't running because the function caller code is still trying to call basic function. When I update it to call the Fibonacci function, the output updates to show the function's internal state. There are no variables except for the input n, but the results are a bit more interesting than before because this is a recursive function, meaning that it calls itself. In the results section, WhiteBox shows the result of the initial function call from the function caller, but then it also shows the result of each recursive call. If we increase the input variable, we can see the number of calls gets a lot larger. We can also see that many of the calls are repeated with identical inputs. This suggests we might want to think about rewriting the function to avoid the repeated work, perhaps with a loop method or caching the results for a given set of parameters. Quite a common pattern in C and C++ is to pass a pointer to a struct which the function will then fill out. This is effectively a type of result, so WhiteBox can show it this way. The output shows the initial value of the pointed to struct, both members zeroed out, the result, which in this case is void, and the final value of the pointed to struct, which is 45.3.14. And when we update the function, as before, the output updates to match. WhiteBox will load and compile functions that are called by the function you are writing, including from hash-included files. Based on a couple of different inputs, it looks like the called function is returning their square. If we check out the hash-included file, you can also see that WhiteBox has detected the change in file and function. We can inspect that function, and we see it is in fact squaring the input. Let's change that to cube the input, basically just because we can. Back to the original file, here's a function that calls out into an already compiled object file. This makes life extra easy for WhiteBox, as the compilation is already done for it. It's also quite a common use case to call into different parts of the codebase that are compiled, or to want to update a small part of that compiled codebase. This also happens to be a var_args function, just to demonstrate that WhiteBox can handle it. Let's try calling a second time with different inputs to compare and see what happens. Coming up with 42 each time, that could be related to the last input to object function. If we try calling with a bigger input than 42, yeah, the result seems to be the largest input greater than that. If we have a look at that file now, again, the output updates to reflect the change in function and file, and object function is run with the inputs from the caller. VA_list is an opaque data type that is just given as a car pointer, so we can't currently inspect it. That's why it looks garbled. You can see how num changes in every cycle of the loop to match the corresponding parameter, and also how the max value only increases. Again, let's just change the input and show how it updates. Thank you for checking out WhiteBox. If you'd like to be updated as the tool progresses, there's a mailing list on the website, whitebox.systems, link below. Please go ahead and subscribe to this channel and follow us on Twitter. And if you have any questions, comments, or suggestions, please feel free to email me at hi@whitebox.systems or message me on Twitter. See you on the next devlog.